Hi, hello there. Welcome to Standard Template Library or STL. So for the objectives, at the end of this video lecture, you should be able to learn about the Standard Template Library or STL. Become familiar with three basic components of STL, which are containers, iterators, and algorithms. Also, explore how vector and deck containers are used to manipulate data in a program, and discover the use of iterators. Let's get started. Components of the STL. The main objective of a program is to manipulate data and generate results. So achieving this goal requires the ability to store data into computer memory, access a particular piece of data, and manipulate that data. Okay, and writes algorithms to manipulate it. So for example, if all the data items are of the same type and we have some idea of the number of data items, we could use an array to store the data. So we can then use an index to access a particular component of the array. Using a loop and the array index, we can step through the elements of the array. So algorithms such as those for initializing the array, sorting, and searching are used to manipulate the data stored in the array. So the STL is equipped with these features to effectively manipulate data. More formally, the STL has three main components. So these are containers, iterators, and algorithms. So containers and iterators are class templates. Iterators are used to step through the elements of a container. So algorithms are used to manipulate data. So this video discusses some of the containers and iterators. Container types. So containers are used to manage objects of a given type. The STL containers are classified into three categories. So first, you've got the sequence container, also called sequential containers. You also have associative containers and container adapters. Let's get into the detail and start with sequence containers. Every object in a sequence container has specific position. The three predefined sequence containers are as follows. You've got vector, deck, and list. So before discussing container types in general, let us first briefly describe the sequence container vector. We do so because vector containers are logically the same as array, and therefore they can be processed like arrays. Okay, so also with the help of vector containers, we can describe several properties that are common to all the containers. So in fact, all containers use the same names for the common operations. Okay, so of course, there are operations that are specific to a container. These operations are discussed when describing a specific container. So this video lecture discusses vector and deck containers. So let's have the sequence container vector. Okay, so a vector container stores and manages each object in a dynamic array. So because an array is a random access data structure, the elements of a vector can be accessed randomly. Item insertion in the middle or beginning of an array is time-consuming, especially if the array is large. However, inserting an item at the end is fast. The name of the class that implements the vector container is vector. So recall that containers are class templates. The name of the header file containing the vector class is vector. So thus, to use a vector container in a program, the program must include the following statement. So something like # include vector. Okay, so furthermore, to define an object of type vector, we must specify the type of the object because the class of vector is a class template. So for example, the statement vector int, and then you've got int list. So it declares int list to be a vector and the component type to be an integer or int. So similarly, the statement vector string list declares a string list to be a vector container and the component type to be a string. Now, declaring vector objects. The class vector contains several constructors, including the default constructor. So therefore, a vector container can be declared and initialized in several ways. So this table here, table 4.1, describes how a vector container for a specific type can be declared and initialized. Okay, so you could refer to the PowerPoint associated with this video, okay, and then look for those vector containers of a specific type. Okay, so if we have here something like vector, the element type, and then vic list. So it creates an empty vector, vic list, without any elements. So the default constructor is then invoked. So the second statement, vector, you've got the element types, vec list, other vec list. So it creates a vector, vic list, and initialize vic list to the elements of the vector other vic list. So vic list and other vic list are of the same type. So the third statement is vector, and then the element type, vic list, and then the size. So it creates a vector, vic list, of the size. So vic list is initialized using the default constructor. So the next statement, vector, element type, vic list, in, and then you've got the element. So it creates a vector, vic list, of n size. Vic list is initialized using n copies of the element lm. Okay, so the last one would be vector, element type, vic list, begin and end. So it creates a vector, vic list. Vic list is initialized to the elements in the range begin and end. That is, all elements in the range begin and then of course end -1. Now the following statement declares int list to be an empty vector container and the element type is integer. So you've got vector int, you've got int list. So the second statement, the following statement declares an int list to be a vector container of size 10. And the element type is integer. So the elements of int list are initialized to 0. Okay? So something like you've got vector int list 10. Okay? Now the third statement here declares int list to be a vector container of size 5. And the element type is integer. So the container int list is initialized using the elements of the array. Okay? So you've got int array, the size is 5, and the elements are 2, 4, 6, 8, and 10. Okay? So the container int list is initialized using the elements of the array, int array. That is int list, and then you've got sets of 2, 4, 6, 8, and 10. Now that we know how to declare a vector sequence container, let us now discuss how to manipulate data stored in a vector container. To do so, we must know the following basic operation. So basic operations includes item insertion, item description, okay, or item deletion, and stepping through the elements of a vector array or a vector container. Now from table 4-2, it follows that the elements in a vector can be processed just as they can in an array. So recall that in C++, array starts at location 0. Okay, so similarly, the first element in a vector container is at location 0. So referring to this example 4-2 here, for letter A, consider the following statement. Okay, so which declares int list to be a vector container of size 5. And the element types is in type integer. Okay, so on letter B, you can use a loop such as the following to store elements into int list. Okay, so something like for int j is equal to 0, j is less than 5, j plus plus. And we are putting the value of j on the int list starting with 0. So similarly, you can use a for loop to output the elements of the int list. The class vector provides various operations to process the elements of a vector container. Okay, so there is an iterator, argument position in STL terminology. Now suppose that vectlist is a container of type vector. So item insertion and deletion and vectlist can be accomplished using the operations given in table 4-3 here. Okay, these operations are implemented as member functions of the vector or class vector and are shown in bold statement. So this table 4-3 shows how these operations are used. Okay, so in this table, the argument position in STL terminology is called iterator. An iterator works just like a pointer. In general, iterators are used to step through the elements of a container. So in other words, with the help of an iterator, we can walk through the elements of a container and process them one at a time. Okay, so something like the expression vectlist.clear, it deletes all elements from the container. Okay, so the assumption here is vectlist is a container of type vector. So the second statement, vectlist.erase, and then you specify the position. It deletes the element at the position specified by the position here. So the third one is vectlist.erase, beginning or begin and end. It deletes all elements starting at beg until end -1. Okay, so same thing with vectlist.insert, position and then the element. A copy of element is inserted at the position specified by the position. So the position of the new element is returned. For the next expression, vectlist.insert, position and end element. So n copies of element are inserted at the position specified by position. Okay? And the last one, vectlist.insert, position, begin, end. A copy of the elements starting at begin until end -1 is inserted into the vectlist at the position specified by the position. Okay? Now, in the next section, we describe how to declare an iterator in a vector container and how to manipulate the data stored in a container. Because iterators are integral part of the STL, they are discussed in detail in the section Iterator. Okay, so for the continuation of the table, so the function pushback is quite useful. Okay, so this function is used to add an element at the end of a container. So when you're given something like vectlist.pushback and then the element, so a copy of element is inserted into the vectlist at the end. You also have the vectlist.popback. it deletes the last element. Okay? So vectlist.resize and then num changes the number of elements to num if size, that is the number of elements in the container, increases. The default constructor creates a new element. And the expression vectlist.resize num and element, it changes the number of elements to num. If size increases, the default constructor creates a new element. Okay? Now, the container int list of size 5 was declared in example 4-2. Okay? So, you might think that you can only add 5 elements to the container int list. However, this is not the case. So, if you need to add more than 5 elements, you can use the function push back. So, you cannot use the array subscripting operator as shown on the video. Okay, so I want you to see video demonstration. Okay, so to add elements past the position 4 unless you increase the size of the container. So in this case, you can use the function pushback as shown on that video lecture or video demonstration to add elements into a vector container. Please see video demonstration or a demonstration associated with this video lecture. Okay? Next, if you do not know the number of elements you need to store in a vector container, then you declare the vector container. You do not need to specify its size. All right? So the following statement declares int list to be a vector container of size 0. Okay? Then for letter B, okay, you've got int list dot pushback 34. Okay, so and then int list dot pushback 55. So after these statements execute, the size of the int list is 2. Okay, and the value of int list would be 34 and 55. All right. So of course, you could have used the size or resize function to increase the size of int list, and then use the array subscripting operator. However, at times, the pushback function is more convenient because it does not need to know the size of the container. It simply adds elements at the end of the container. Even though we can process a vector container just like an array using the array subscripting operator, there are situations where we could like to process the elements of a vector container using Iterator. Okay? So recall that an iterator is just like a pointer. So for example, suppose that we want to insert an element at a specific position in vector container. Okay? So because the element is to be inserted at a specific position, this would require shifting the elements of the container unless the element is added at the end. So of course, we must also think about the size of the container. To make elements insertion convenient, the class vector provides the function insert to insert the elements at a specific position in a vector container. However, to use the function insert, the position where to insert the elements must be specified by an iterator. So similarly, the function erase, okay, to remove an element also requires the use of an iterator. So this section describes how to declare and use an iterator on a vector container. So the class vector contains a typedef operator or typedef iterator, which is declared as a public member. Okay? So for example, the statement vector, okay, int iterator int vec iter. It declares int vec iter to be an iterator into a vector container of type int. Because iterator is a type def defined inside the class vector, we must use the container name vector. Okay, so container element type and the scope resolution operator, just like in a class, to use the def iterator. Okay. Now suppose that iterator int vector points to an element of a vector container whose elements are of type int. So the expression ++ int vec iter advances the iterator int vec iter to the next element into the container. Okay? So the expression *int vec iter returns the element at the current iterator position. So note that these operations are the same as the operations on pointers. Okay, so recall that when used as a unary operator, asterisk is called the referencing operator. Okay, so we now discuss how to use an iterator into a vector container to manipulate data stored into it. Suppose that we have the following statement here. So vector int list, and then vector int scope resolution operator, iterator, int vec iter. So line 1 declares int list to be a vector container and the element type to be integer. Okay? Now line 2 declares int vec iter to be an iterator into a vector container whose element type is integer. Containers and the functions begin and end. Okay? So every container contains the member functions begin and end. So the function begin returns the position of the first element into the container. And the function end returns the position of the last element into the container. Now this functions has no parameters. Okay? And class vector contains member functions used to find number of elements currently in the container. Okay, now referring to this example here, okay? So say int vec iter is equals to int list.begin and then open and close parentheses. So the iterator int vec iter points to the first element into the container int list. Okay? Now the following statement, okay, using for loop uses an iterator to output the elements of int list onto the standard output device. Okay? So our declaration for int vec iter is equals to the int list.begin, okay, until int vec iter is not equal to the int list.end, and then you've got int vec list. So see out, you've got asterisk, so this is a pointer here, okay, with the reference operator, of course. Okay, so this means this loop uses an iterator to output the elements of int list onto the standard output device, in that case our monitor. All right, so take a look at example 4-4 here. Okay, so int array 7, so the values are 1, 3, 5, 7, 9, 11, and 13. Okay, now vector int vec list int array plus 7. Okay, now the statement in this line 2 declares and initializes the vector container vec list. Now consider the following statements here. Okay, now int vec iter is equals to vec list.begin, okay, on line 4, and then plus int vec iter on line 5, and then vec list.insert int vec iter 22. Okay, now line 4 initializes the iterator int vec iter to the first element of vec list, so that is via begin. Now the statement in line 5, okay, advances the int vec iter to the second element of vec list. because of the plus plus int vec iter. Okay? The statement in line 6 inserts 22 at the position specified by int vec iter. So after the statement in line 6 executes, so vec list would be 1, you've got 22, okay? And then 3, 5, 7, 9, 11, and 13. Okay? So notice that the size of the container also increases. So the class vector also contains member functions that can be used to find the member of elements currently in the container. So the maximum number of elements that can be inserted in a container and so on. So this table here describes some of these operations. Suppose that vec_cont, okay, is a vector container. So if you are having vec_cont.capacity, it returns the maximum number of elements that can be inserted into the container vec_cont without reallocation. Okay, so that is vec_cont.capacity. Now vec_cont.empty, it returns true if the container vec_cont is empty and false otherwise. Now vec_cont.size returns the number of elements currently in the container vec_cont. Okay, and then the last expression, if you have something like vec_cont.maxSize, it returns the maximum number of elements that can be inserted into the container vec_cont. Okay, so again, our assumption here that a vec_cont is a vector container. Now this time I want you to see the video demo STL dem 00 or demo 01. Okay, so please check the playlist and look for STL demo 01. Member functions common to all containers. So the previous section discussed vector containers. We now look at operations that are common to all the containers. For example, every container class has a default constructor. Okay? Several constructors with parameters and a destructor. So a function to insert an element into a container and so on. So recall that a class encapsulates data and operations on that data into a single unit. Because every container is a class, several operations are directly defined for a container and are provided as part of the class definition. Okay? So also, recall that the operations to manipulate the data are implemented with the help of functions that are called member functions of the class. All right? Now, I have here table 4-5, which describes the member functions that are common to all containers. Okay, so that these functions are included as members of the class template implementing the container. So suppose that CT, okay, and then CT1 and CT2, okay, are containers of the same type. So table 4-5 shows the name in the function in bold and shows how the function is called. Okay, so something like city.empty, it returns true if the container city is empty and false otherwise. So city.size returns the number of elements currently in the container city. City.maxSize returns the maximum number of elements that can be inserted into container city. Okay, so you also have the ct1.swap ct2. Okay, swaps the data elements or the elements of containers ct1 and ct2. Okay, so you just have to use those functions. So city.begin returns the iterator, okay, to the first element into container city, while city.end returns an iterator to the last element into container city. Okay, so you also have city.rbegin or reverse begin. It returns a pointer to the last element into container city. This function is used to process the elements of city in reverse. You also have city.rend or reverse end. So it returns a pointer to the first element into the container city. Now city.insert, specifying the position and then the element, it inserts lm into container city at the position specified by the argument position. So take note that here position is an iterator. And city.erase begin and end. So it deletes all the elements between begin and end -1 from container city. Okay? Now, because these operations are common to all containers, when discussing a specific container, to save space, these operations are not listed again. All right? So you could also perform something like city.clear deletes all the elements from the container after a call to this function container city is empty. So other operators can also be used. Okay, something like city1 equals city2, it means copies the elements of city2 into city1. So after this operation, the elements in both containers are the same. Okay? You could also have city1 equals city2. It returns true if container city1 and city2 are equal. So you are doing comparison here. Okay? And of course, false otherwise. Now, city1 is not equal to city2. It returns true if the container city1 and city2 are not equal and false otherwise. All right? So city1 is less than city2. It returns true if the container city1 is less than container city2. False otherwise. Okay? So city1 is less than or equals to city2. It returns true if container city1 is less than or equal to container city2 and false otherwise. So the next expression, okay, city1 is greater than city2. So it returns true if container city1 is greater than city2 and false otherwise. And the last one, city1 is greater than or equals to city2. Returns true if the container city1 is greater than or equal to the container city2 and false otherwise. So you can perform these operator functions, okay, so for these containers. Now, the previous section describes the member functions that are common to all containers. So in addition, okay, this table here, table 4.6, describes the member functions that are common to all sequence containers. That is, containers of type vector, deck, and list. Now, suppose that sequence cont, no, or seq_cont is a sequence container. So you could perform insert, okay, position, and elements. The effect would be a copy of lm is inserted to the position specified by position. So the position of the new element is returned. So also, say you've got seq_cont, insert position and then elements. So n copies of lm are inserted to the position specified by position. Okay? So you could go ahead and try this on your computer. Okay? seq_cont.insert position, begin and end. So this means a copy of the elements starting at beg until end -1 are inserted into the seq_cont at the position specified by position. Okay? So seq_cont.pushback element, a copy of the element is inserted at the seq_cont at the end. So take note that pushback will insert the element at the end. Okay? Now seq_cont.popback, definitely this is just the opposite of pushback. It deletes the last element. All right? So also, you can use seq_cont.erase and then position. So if you want to delete the element at the position specified by position, so you can execute this command. Okay? Again, the assumption is seq_cont is a sequence container. Now also, if you are given seq_cont.erase begin and end, so it deletes all the elements starting at begin and end -1. Okay? seq_cont.clear deletes all the elements from the container. And seq_cont.resize and then the number it changes the number of elements to num. So if size grows, the new elements are created by their default constructor. Okay? And then sec_cont.resize, number and then element, it changes the number of elements to num. If size grows, the new elements are copies of lm. All right? So again, on this table, our assumption is sec_cont is a sequence container.